Hi, everybody. Mr. Gilbert.
And Mr. Kimpton.
Back to do a little bit about relative dating, pages 110 to 115 in your book.
By the end of this section, there's 4 things for sure that you should know. One of them is how common sedimentary rocks form and from what.
The law or principle of superposition and how to apply and use it with geologic columns and what they can tell us about the past.
What is an index fossil and how do they tell us something about the past?
And how unconformities and disturbances affect the record and what they can tell us about the past.
All right, sedimentary rocks form from sediments. You could probably imagine that, or crushed rock bits, weathered and eroded rock material, and they're compacted and cemented together.
And in class, you're going to see and check out a whole bunch of common sedimentary rocks. But, basically there's 4 really common ones. Sandstone used to be sand, got compacted and cemented together to form a rock. Shale used to be mud that got compacted and cemented together to form a rock. Siltstone used to be silt, very, very small sedimentary pieces, got compacted and cemented together. That formed a rock. And limestone used to be corals and shells, etc., that got compacted and cemented together to form a rock. Limestone did not used to be limes.
Crunchy sea creatures.
Crunchy sea creatures, sweet.
All right, so sedimentary rock layers, don't copy this down, just think, are formed by the following rules. First, the sediments, sand, mud, crushed corals, all that stuff, are laid down flat, then compacted and cemented together to form into rocks. The oldest rocks are at the bottom, which we'll talk about in a little bit, and the youngest rocks are at the top.
Just like if you're pouring layers of cake into a pan, the first step there is at the bottom, the last one at the top.
Or it's like your laundry basket.
Ooh,
what
laundry.
You wore yesterday, hopefully is on top, and what you wore last week, hopefully is on the bottom.
Nice. Here's the but. But due to folds, faults, dikes, and erosion, if you're not sure what those are, ask in class, because in class we go over it. These flat layers may break, change, bend, and are no longer flat. Okay? And there's the last thing is a dike, a magma intruder coming from inside the earth, is younger than any rock layer it passes through. The rock layer has to be there for the dike to come up and melt through it. Therefore, the dike is younger. So we can summarize this. Mr. Kimpton, the honor is you.
All right. Well, the principle of superposition, or law, whatever you want to call it, within flat sedimentary rock layers, the layers on bottom are older than the layers on top. Those are younger, even taking into account all of the disturbances, folds, faults, dikes, or intrusions, and erosion.
Sweet. So why is this important? Well, we use this superposition law or principle to determine the relative dates of rock layers in a column. Okay? In other words, layers of rocks. Oldest at the bottom, youngest at top. And therefore, we can suggest what geologic events occurred in the past to form those rock layers and how things have changed. But there's something you kind of got to know, and that's index fossils. We learned about fossils earlier. An index fossil is a fossil we know the age of by relative or absolute dating techniques, and the fossil was only alive for a little bit of geologic time. It wasn't alive for millions and millions and millions and millions of years, just a little bit of time. So it's really easy to pinpoint when or index when that fossil was around.
And here you have you'll hear us talk about geologic columns. So it's a column of rock, and we can take these rocks, or you can think of like big core samples or road cuts where you see all those stripy rock layers. That's what we're looking at all the time in geology. It's an arrangement of rock layers in which the oldest rocks are at the bottom. We can take these from like all around the country and we can match them up like a puzzle, and that's how we know all these different rock layers exist in different parts of the world.
Sweet. Okay. So a little midterm review. Relative dating. We're going to figure out which rock came first. Any method that determines if an object or an event is older or younger than another object. In other words, use the law of superposition to figure out the age relative to the other layers. Okay. Now we're going to get some examples of superposition. We've done that one. Disturbances and unconformities. Remember, rocks are not just rocks. Rocks are record of past events.
So here we go. We probably don't do this anymore with photos because they're all on our hard drive. But if we were, The photos that we just took last week and got developed should be at the top, and the photos from 2 years ago are at the bottom. So if you look at this road cut here, you can see where they blasted away a hill, and you see all those different stripes. So where the road is, where that red car is flying by, those rocks are going to be older than the rock layer that's just below the soil line or where the trees are up at the top. So present time is up at the top.
Sweet. So there are other types of disturbances, things that bust up your rock column. And what goes on? Of course, we said we talked about these. Here's a fault, a crack or break in the rock where movement occurs. One side of the fault went down, the other side of the fault went up, so that the rock layers don't exactly line up anymore. So you got to solve the puzzle and put them in place. An intrusion or a dike is when magma comes up and melts through a rock layer. In the picture, you can see that real well, coming from the center. Remember, an intrusion or dike is younger than everything it passes through.
It's hard to intrude something if there isn't anything there.
Oh, that's good. That's good. We got folding. If you apply compression to a rock, you squeeze it together, it's not going to be flat. You're going to get these folds in there. Same thing, youngest on the bottom. Oldest on the bottom, youngest on top.
It's like hamburger meat.
Ooh, yeah. And then sometimes things tilt. The whole, look at this. This is not flat anymore. All these rock layers have tilted. Don't look at the green grass growing there. Look at the layers. And that can be from compression put in, tilting up the whole area. These are disturbances, and they tend to make the law of superposition a little bit more exciting to figure out.
All right, so what if the geologic column looks odd, or it doesn't look right? Something's missing. Okay, well, usually that means there's what's called an unconformity. It does not conform to the pattern you think it should. Unconformities are where erosion has removed some rock layers in a geologic column. So you'll be able to see that something is missing. So how do unconformities affect the principle of superposition? Here's a nice visual. Sometimes an unconformity exists, all right? So if we look here at the first picture, it's showing you like two options of how rock could be laid down. So you have sediment washing into, say, a river valley or something, all right? And then you have, the best example would probably go down. So where you have uplift and that material is exposed above that hill. And then you have wind, water, some type of weathering and erosion, and it wipes away, as you can see, some of that top layer, but also that hill, whatever that other rock type or material was. So
gets rid of it, erodes it away.
Yep, you're not going to just have like a clear line that zips things off usually. That means something has happened and is missing. So in this last picture here in the bottom right corner, that inconformity line where they're pointing, that dotted line, is where it looks like there's something missing. You know that there should be some hill there and a little bit more sediment, and there isn't. And then new material, bam, a whole other story starts on top.
So the top story, the newest one, is on top of these things that don't line up. They don't conform. Sweet. Oh, geez, next slide. Hey, let's look at something real. Like the Grand Canyon.
Great. If you've ever been there, it's pretty cool. Just don't fall in.
So we got a little picture of the geologic column of the Grand Canyon. It's kind of, here it is in real life, and here it is again. And it tells you how old the different rock layers. This sandstone, 260 million years. This one's 255. This one's 250. Of course, as you go towards the surface, they get younger. So how old could this dead fossilized fish be? Well, it would be older than 260 million years. I didn't let you see how old it is. Why is it older than 260? Because it's below the rock layer that's 260 million years old.
Page 111 in your book shows almost the same exact picture, and we're pretty much answering it for you. So take a look at that.
Oh, nice hint.
Yeah.
So here's kind of a few things that occurred over time to get unconformities, etc. I mean, you got rock layers laid down flat. You get a little folding there. It's still oldest at the bottom, youngest at the top. You get erosion coming by, wiping things, creating a flat layer. Still the oldest at the bottom, youngest at the top. And then now we have our unconformity, because above these curved layers, you get flat layers. Well, always get out looking, because you're going to have to figure out what's going on here. What type of disturbances are in these four pictures?
So here's some great photos from the real world. And in class,
that's Mr. Kimpton.
In the class, that we're going to ask you to label these. We could help you out with that right now, so you can be a whiz kid in class. A fold, upper left-hand corner. you can see that fold, that nice curve. It's almost going to start to fold back up on the other side. The one on the top right, you can see that rock it looks like it hasn't been turned into an unconformity yet, but it's being weathered and eroded, but it's at a different angle from the line of the horizon.
So that's tilt?
That would probably be tilted.
Oh,
yeah,
yes.
You could get out your protractor and measure if you want, but that's some major force in Earth. Then, bottom right, this looks like a huge piece of like some type of cheesecake or something, but you can see how the Earth is actually shifted. That gray, probably some type of clay layer, is not matched up on the other side of the fault line. Things have shifted. And then my favorite on the left is this intrusion. So you had some igneous rock, which means it came from magma, and it melted its way up through what looks like some red sandstone. So it'll look really weird. Okay, and this magma just rises up, and then it cools, and then you get this weird monster-looking stripe. That's going to be an intrusion.
Hey, we hope you took some good notes and are ready to go with all this fun stuff about superposition and how it works and what it can tell us about the past.
It rocks.
It rocks.